Hello and welcome. Tonight or today, whenever you're joining me, we're going to do something very simple. We're going to lie back, breathe slowly, and let our minds drift out past the roof of your room, past the clouds, past the moon, and out into the quiet dark of the universe. There's no rush here, nothing to solve, nothing to remember, just facts. Gentle, true, astonishing facts about the cosmos we live in, told slowly, one after another, like counting stars instead of sheep. If you're here to relax, to fall asleep, or just to feel small in the best possible way, you're in the right place. Let's begin. The universe is bigger than you can imagine, and that's okay. Let's start with scale, because everything else we talk about tonight rests on this one gentle truth. The universe is big, almost incomprehensibly big, and there is a strange comfort in that. Number one, the universe is bigger than you can imagine, and that's okay. Let's start with scale, because everything else we talk about tonight rests on this one gentle truth. The universe is big, almost incomprehensibly big, and there is a strange comfort in that. The observable universe, the part we can actually see, limited only by the speed of light and the age of the cosmos, is about 93 billion light years across. Not 93 billion miles, 93 billion light years. A single light year is already about 9.5 trillion kilometers. The distance light travels in 1 year, moving at 300,000 kilometers every second. Try not to picture the number. Numbers like that stop meaning anything after a while. That's normal, and it's fine. Instead, just picture the feeling of it. Vast, dark, quiet, endless. Here's a softer way to hold this fact. If you shrank the entire Earth down to the size of a single grain of sand, the sun would be about the size of a marble, roughly 15 meters away. Neptune, the outermost planet, would be nearly half a kilometer from that marble. And the next nearest star to our sun, Proxima Centauri, would be another marble over 4,000 kilometers away. Between the stars, there is almost nothing. Space is overwhelmingly empty space. Cold, dark, silent distance. And yet, here you are. A small, warm, breathing thing on a small, warm, breathing planet, tucked safely into all of that emptiness. You don't have to understand the numbers. You just have to notice how small your worries look next to something that big. Let's sit with that scale a moment longer. The Milky Way, our home galaxy, contains somewhere between 100 and 400 billion stars, just our galaxy. And the observable universe contains somewhere around 2 trillion galaxies, each one on average home to hundreds of billions of stars of its own. You are not required to hold that number in your head. Nobody can really. Even astronomers who work with this scale every day describe it the same way you might, with a kind of quiet, humbled awe. There is something very relaxing about being this small. It means most things that feel urgent to you tonight are not, in fact, urgent to the universe. The stars will keep shining whether you finish your to-do list or not. The galaxies will keep turning slowly, silently, whether you fall asleep in 5 minutes or 50. You are allowed to let go, tonight, inside something this big. Number 2, you are made of stardust, literally. Here is one of the gentlest facts in all of astronomy, and one of my favorites to share slowly, like this. Almost every atom in your body, heavier than hydrogen, was forged inside a star. Carbon in your cells, calcium in your bones, iron in your blood, carrying oxygen through your body right now as you listen to this. All of it was cooked over millions of years in the nuclear furnace at the heart of a star that lived and died long before the sun ever formed. When a massive star reaches the end of its life, it can explode in a supernova, one of the most energetic events in the universe. For a few weeks, a single dying star can outshine its entire galaxy. And in that explosion, It scatters the elements it spent its life creating out into space in an expanding cloud of gas and dust. That dust drifts for millions, sometimes billions, of years. It slowly gathers, pulled together gently by gravity, mixing with other clouds, other scattered elements from other long-dead stars. And eventually, patiently, some of that dust becomes a new star. Some of it becomes planets. Some of it becomes oceans and mountains and forests. And some of it becomes you. The astronomer Carl Sagan liked to say that we are a way for the universe to know itself. I like to think of it a little more simply. The same processes that light up the night sky also, eventually and very patiently, made you. Your body is old, not in years, but in atoms. The iron in your blood may be older than the earth itself. It has been through the heart of the star, through an explosion bright enough to be seen across galaxies, through millions of years of drifting silently through the dark, just to end up here, quietly keeping you alive while you rest. You don't have to do anything with this fact. Just let it sit with you. You are old. You are made of the same material as the stars above you. You have always, in some form, belonged to this universe. Let's slow down even further and talk about something even quieter: silence itself. Number 3, space is silent. If you could stand outside in open space without a suit, you would hear absolutely nothing. Not a hum, not a hiss, not even the faint white noise you might expect. Total silence. Sound needs something to travel through: air, water, some kind of matter whose particles can bump into each other and carry vibration along. Space, for the most part, is a vacuum. There's nothing there to carry the wave. So even the most violent events in the universe, a star exploding, 2 black holes colliding, a galaxy tearing another galaxy apart with gravity, happen in complete silence. Some of the most dramatic events imaginable, and they make no sound at all. Now, you may have heard sounds from space, recordings labeled as the hum of Saturn or the song of a black hole. Those are real, but they're translations. Scientists take other kinds of waves, radio waves, plasma vibrations, or shifts in pressure captured by instruments, and convert them into sound waves we can hear, the way you might turn a graph into a melody. It's beautiful, and it's real data, but it isn't sound traveling through space the way your voice travels through the air in your room right now. In space itself, everything happens in silence. There's something worth borrowing from that. Here in your own quiet room tonight, silence isn't empty. Silence isn't nothing. It's simply the natural state of most of the universe, the space between things where the biggest events of all quietly unfold. If it's quiet around you right now, you're not missing anything. You're simply resting the way most of the universe rests, peacefully and without a sound. Number 4, time moves differently than you think. Here's a fact that tends to make people feel strangely calm once it settles in. Time is not the same everywhere. We tend to think of time as a steady beat, ticking the same way for everyone, everywhere. But Einstein showed us over a century ago that time is flexible. It bends, it stretches. It moves slightly slower the faster you travel, and slightly slower the closer you are to a strong source of gravity. Astronauts on the International Space Station, for instance, travel so fast, about 28,000 kilometers per hour, that their clocks run very slightly slower than clocks on Earth. Over months in orbit, they end up a few milliseconds younger than they would have been if they'd stayed home. A tiny amount, but real, measured, confirmed. Near a black hole, the effect becomes extreme. If you could somehow hover near the edge of a black hole's event horizon and then return to Earth, you might come back to find that decades or centuries had passed for everyone else, while for you, only a few hours went by. Time near a black hole doesn't stop. It just moves at a different pace than the time you and I are sharing right now. There's something soothing in realizing that time itself, the thing we feel so pressured by, the thing that makes us feel like we're always behind, isn't even a fixed, universal rule. It bends depending on where you stand and how fast you're moving. Your sense of running out of time is a very human, very earthbound feeling. Out there, time is more like a slow, patient river that moves differently depending on the terrain. Tonight, your only job is to let your own time slow down. No spaceship required. Number 5. The sun's quiet, endless rhythm. Let's come back closer to home for a while, to something steady and familiar, our sun. Every single second, the sun converts about 600 million tons of hydrogen into helium in its core, releasing an almost unimaginable amount of energy in the process. It has been doing this steadily for about 4.6 billion years, and it will keep doing it steadily for roughly another 5 billion years. Think about that rhythm. Every second for billions of years, without pause, without rest, the sun has been quietly burning, and every single one of those seconds, some of that light and warmth eventually reaches Earth, ripens fruit, warms oceans, and lets flowers turn slowly to follow it across the sky. Sunlight takes about 8 minutes and 20 seconds to reach Earth. So whenever you feel the sun on your skin, you're feeling light that left the sun's surface a little over 8 minutes earlier. A small, quiet reminder that even light, the fastest thing in the universe, still takes its time. The sun is extraordinarily stable. It doesn't flicker or waver the way a candle does. It has been shining with remarkable consistency for billions of years, which is part of why life on Earth has had the calm, steady conditions it needed to slowly take shape. There's a kind of reassurance in that. Somewhere above the clouds right now, whether you can see it or not, the sun continues its slow, steady rhythm. The same rhythm it has kept for billions of years. The same rhythm it will keep for billions more. Some things really are that reliable. Number 6. Looking at the sky is looking into the past. Here's a fact that changes the way you might look at the night sky forever, in the gentlest way. Because light takes time to travel. Whenever you look up at the stars, you aren't seeing them as they are right now. You're seeing them as they were, sometimes a few years ago, sometimes thousands of years ago, sometimes millions. The star Sirius, the brightest star in our night sky, is about 8.6 light years away. So its light left it 8.6 years before it reached your eyes. The Andromeda Galaxy, the closest large galaxy to our own, is about 2.5 million light years away. When you look at Andromeda on a clear, dark night, you're seeing light that began its journey 2.5 million years ago, long before modern humans existed. Some of the light reaching Earth's telescopes tonight left its source before the pyramids were built. Some left before the dinosaurs existed. Some of it, from the most distant galaxies we can detect, left more than 13 billion years ago, when the universe itself was still young. In a very real sense, the night sky is a window into the past. Every time you look up, you are looking backward in time, layer upon layer, star behind star, each one further back than the last. And in that light, think about this slowly. Some of the stars you might be picturing right now may not even exist anymore. They may have already changed or dimmed or ended, and we simply haven't received the news yet because the light hasn't reached us. There's something oddly comforting in that too. The past isn't gone out there. It's still arriving, still traveling toward us, patiently, across unimaginable distances. Nothing in the universe is in a hurry. You don't have to be in a hurry either. Number 7. Earth's quiet shield. Let's talk for a while about the very thin, very precious layer of protection wrapped around our planet. Earth's atmosphere is remarkably thin compared to the size of the planet. If you shrank the Earth down to the size of an apple, the breathable atmosphere would be thinner than the apple's skin. And yet, within that thin skin of air, our entire lives take place. Every breath, every sunset, every cloud, every storm. Beyond the atmosphere, Earth is also protected by something called the magnetosphere, an invisible magnetic field generated deep within the planet's molten iron core. This field extends far out into space and deflects most of the charged particles constantly streaming from the sun, known as the solar wind. Without it, that solar wind would slowly strip away our atmosphere, the way it likely did to Mars billions of years ago. So right now, while you rest, an invisible magnetic shield, generated by the slow churning of molten metal thousands of kilometers beneath your feet, is quietly deflecting a stream of charged particles from a star 150 million kilometers away. It's easy to forget how much quiet protection surrounds us at all times. The atmosphere above you, the magnetic field around the planet, the vast gravitational balance that keeps Earth in a stable, gentle orbit around a stable, gentle star. None of it asks for your attention. It simply continues, steadily, whether you notice it or not. You are being held right now by forces far older and far larger than you. Held gently in place, protected, cushioned, without having to do anything at all to deserve it. You can rest inside that. You don't have to hold yourself up. You already are being held. Number 8. Everything returns, slowly. Let's talk about cycles for a while. One of the most calming ideas in astronomy. We already talked about how stars die and scatter their elements into space, and how those elements eventually form new stars and new planets. This isn't a one-time event. It's a cycle that has been repeating for over 13 billion years, and will keep repeating for a very long time to come. Our own sun is thought to be what's called a third or later generation star, meaning the material that formed it was already recycled from earlier stars that lived and died before it. Someday, billions of years from now, when the sun reaches the end of its life, it will swell into a red giant, gently shed its outer layers into space, and leave behind a small, dense core called a white dwarf. The material it sheds will drift outward, slowly, patiently, and over time. Some of it may become part of new stars, new planets, maybe even new life, somewhere else, someday. Nothing in the universe is really wasted. Matter is passed along, recycled, transformed, reused, not destroyed. The atoms that make up the chair you might be sitting in, a blanket wrapped around you, the breath in your lungs, they will outlive you, outlive this planet, and continue on in some new form, long after tonight is forgotten. There's a deep, slow comfort in that. Endings in the universe are rarely final. They're transformations. A star's death becomes a nebula. A nebula becomes new stars. New stars become new planets. New planets sometimes become home. Whatever feels heavy tonight, you don't have to carry it forever. Things change. Things transform. Slowly, gently, the way stardust becomes starlight becomes new stars again. Number 9. The universe has nowhere to be. We're getting close to the end now, so let's slow down even further. The universe is about 13.8 billion years old. That's an old, patient number. And based on what we currently understand, it will keep expanding slowly, gently, for an extraordinarily long time into the future. Some models suggest it will continue for trillions upon trillions of years, far longer than it has already existed. As stars gradually burn out, galaxies drift further apart, and the universe settles into a long, quiet, mostly dark future. This isn't a sad fact. It's a slow one. The universe isn't rushing toward some deadline. It has nowhere it needs to be, and no particular hurry to get there. Galaxies drift apart at a gentle, steady pace. Stars burn for millions or billions of years before fading. Even the most dramatic cosmic events, collisions, explosions, mergers, happen against a backdrop of almost incomprehensible patience. If the universe itself doesn't feel rushed, if it's content to take billions of years to do anything, maybe that's permission for you too to slow down tonight, to stop rushing your own breathing, to stop rushing your own thoughts, to let your evening or your effort to fall asleep take exactly as long as it takes. There is no cosmic deadline for you tonight. There never really was. You are a small, warm, temporary, wonderful arrangement of stardust, resting safely on a small, warm, temporary, wonderful planet, held in place by gravity and time and a thin blue shield of air, somewhere in the middle of an old, patient, silent, endlessly unfolding universe that has absolutely nowhere else it needs to be. Neither do you. Number 10. The oldest light there is. There is a kind of light that fills the entire universe, in every direction, all the time. And it is older than any star, any galaxy, any planet you could name. It's called the cosmic microwave background, and it is the afterglow of the very beginning of everything. About 13.8 billion years ago, the universe was unimaginably hot and dense. For its first few 100,000 years, it was so hot that light itself couldn't travel freely. It kept bouncing off charged particles, trapped, the way fog traps a beam of light and scatters it in every direction. Then, slowly, as the universe expanded and cooled, something gentle happened. The particles calmed down enough to form neutral atoms, mostly hydrogen, and suddenly there was nothing left to scatter the light. It was set free. That light has been traveling through space ever since, stretching and cooling as the universe itself has stretched. And it is still arriving right now, from every direction in the sky at once. Today, that ancient light has cooled to just a few degrees above absolute zero. It's far too faint and stretched to see with your eyes, but sensitive instruments can detect it easily, filling the whole sky like a soft, even hum. If you could see in microwaves instead of visible light, the entire sky, in every direction, would glow faintly with this same ancient light, the oldest light in existence, a photograph of the universe when it was only a few 100,000 years old. Think about that for a moment. Wherever you look, in every direction, without exception, there is a message from the very beginning of time, still arriving, still traveling, patient and constant. It has been traveling for longer than the Earth, the Sun, or almost anything else you know has existed. And it isn't rushing to get anywhere. It simply keeps arriving gently, evenly, the same in every direction, filling the whole universe like a quiet, steady breath that has never stopped since the moment it began. There's something soothing about a light that old, that patient, that evenly spread through everything. It asks nothing of you. It doesn't flicker or startle. It has simply been there quietly since almost the very start, and it will keep arriving long after tonight, long after any of us, still filling the sky with the same soft glow it always has. Number 11, rings made of ice and a planet that could float. Let's drift a little closer to home now, out towards Saturn, one of the gentlest, most graceful sights in our own solar system. Saturn's rings are not solid. They are made of countless small pieces of ice and rock, ranging from grains of dust to chunks the size of a house, all orbiting the planet together in a wide, flat, shimmering disk. Some of these ring particles are made almost entirely of water ice, and they're so reflective that Saturn's rings are actually one of the brightest things in our solar system, easily visible even through a small backyard telescope. Despite stretching hundreds of thousands of kilometers across, wider than the distance between the Earth and the Moon, the rings are extraordinarily thin. In most places, they're only about 10 meters thick. If you scaled Saturn down to the size of a dinner plate, its rings would be thinner than a sheet of paper. A vast, shining structure, and yet impossibly delicate. And here's a gentle, almost funny fact to sit with. Saturn itself is the least dense planet in our solar system. Its average density is lower than water. If you could somehow find a bathtub big enough, Saturn would float. Of course, You'd never actually get to see that happen. Saturn has no solid surface to hold it together outside of water, and no ocean in our solar system is anywhere close to large enough. But the physics is real and true. This vast, ringed, glowing planet, larger than 700 Earths could fit inside, is, on average, lighter than the water in your kitchen sink. There's something delightfully unserious about that fact in the middle of all this vastness. Not everything about the universe has to feel heavy or overwhelming. Sometimes it's simply strange and light and a little bit funny. A giant, glowing, ringed planet drifting slowly through the dark that would float in your bathtub if you had one big enough to hold it. Number 11. It rains diamonds on some planets. Here's a fact that sounds like something from a dream, but is quite likely true. Deep within the atmospheres of Jupiter and Saturn, and probably Uranus and Neptune as well, scientists believe it may literally rain diamonds. Here's roughly how it works. These giant planets have thick atmospheres containing methane. Lightning storms within these atmospheres can break methane down into carbon. As that carbon sinks deeper into the planet, the pressure and temperature increase dramatically, and under those extreme conditions, the carbon is thought to compress into solid chunks of diamond, some perhaps as large as a few millimeters across, falling slowly, steadily, like hail, down through thousands of kilometers of atmosphere toward the planet's core. On Neptune and Uranus especially, models suggest this diamond rain may be common, falling gently and continuously, deep in atmospheres so thick and dark that no telescope could ever actually watch it happen. It's a quiet, hidden weather pattern, unfolding for billions of years, far from any eyes at all. There's something wonderfully strange about that. Somewhere out there, right now, in the deep atmosphere of a distant ice-blue planet, diamonds may be falling slowly through clouds of gas, unseen by anyone, in complete silence and darkness, simply because that is what the physics of that place allows. The universe doesn't need an audience to keep being beautiful. It doesn't perform for us. It simply continues, quietly, magnificently, whether or not anyone is watching. You don't need an audience either tonight. You're allowed to simply exist quietly, without anyone needing to see it, the same way diamonds may be falling right now on a planet 4 billion kilometers away. Number 13. The densest things we know. Let's talk for a while about neutron stars, some of the strangest, most extreme objects in the universe, and yet, in their own way, oddly peaceful to think about. When a massive star runs out of fuel and collapses, sometimes what's left behind isn't a black hole, but something almost as strange. A neutron star. These are the collapsed cores of once giant stars, but compressed down into a sphere only about 20 kilometers across, roughly the size of a city. The density involved is difficult to even describe gently. A single teaspoon of neutron star material would weigh about as much as a mountain here on Earth. Some estimates put it at around 1 billion tons. The gravity at the surface of a neutron star is so strong that if you dropped an object from just 1 meter above its surface, it would strike the ground at a significant fraction of the speed of light. And yet, despite this almost unbelievable extremity, neutron stars can be remarkably steady, calm objects once formed. Many of them spin extremely fast and extremely regularly, sweeping beams of radiation out into space like a lighthouse. These are called pulsars, and some of them spin hundreds of times per second, with a timing so precise that astronomers have used them as natural clocks, almost as accurate as the atomic clocks we build ourselves. There's something quietly astonishing about that, an object so violent in its birth, formed from the collapse of a dying star, and yet so steady, so rhythmic, so reliable once it settles. A gentle, sweeping pulse of light, over and over, thousands of light years away, keeping time in the dark with a precision that puts almost anything on Earth to shame. Even the most extreme things in the universe, it seems, tend to find their way toward a steady rhythm eventually. Number 14. Ripples you can't see but can feel. Here is one of the newest and, to me, one of the most beautifully strange discoveries in modern astronomy: gravitational waves. In 1915, Einstein predicted that massive objects moving through space, especially violent events like two black holes spiraling into each other, should send ripples out through the fabric of space and time itself, the same way a stone dropped into a pond sends ripples out across the water. He predicted this, but doubted we would ever actually detect something so faint. For 100 years, no one could. Then, in September 2015, scientists using an incredibly sensitive instrument detected a tiny stretching and squeezing of space itself, a ripple from two black holes, each dozens of times the mass of our sun, that had collided over 1 billion light-years away. The signal lasted a fraction of a second. The actual distortion it caused here on Earth was smaller than the width of a proton. Smaller than the width of a proton. And yet, we detected it. We felt faintly the echo of two black holes colliding over 1 billion years ago, in a galaxy we will never see with our own eyes. Since then, dozens more of these ripples have been detected, colliding black holes, colliding neutron stars, entire cosmic events that we would otherwise have no way to know ever happened, whispering to us across the very fabric of space and time itself. There's something moving about that. Even the most violent events in the universe, two black holes tearing into each other, unimaginable amounts of energy released in an instant, eventually settle into nothing more than the faintest of ripples, so gentle that they can pass through the entire Earth and barely be felt at all. Even catastrophe, from far enough away, softens into something almost like a whisper by the time it reaches you. Number 15. Thousands of other worlds. For most of human history, we didn't know for certain whether any planets existed beyond our own solar system. Now, we know of more than 5,000 confirmed exoplanets, planets orbiting other stars, and the true number across our galaxy alone is almost certainly in the billions. Some of these worlds are strange beyond anything in our own solar system. There are planets made almost entirely of exposed rock, so hot that their surface may be a slowly flowing ocean of lava. There are gas giants so close to their star that a year one full orbit lasts only a few Earth days. There's a planet discovered around a pulsar, thought to be made largely of crystallized carbon. Essentially, an entire world of diamond orbiting silently in the dark. There are also more quietly, more gently, a growing number of small, rocky worlds discovered within what astronomers call the habitable zone of their star, not too close, not too far, where temperatures might allow liquid water to exist on the surface. We don't yet know if any of them have life. We may not know for a very long time. But simply knowing they're there, scattered gently across the galaxy, each one circling its own quiet star, is enough to make the night sky feel different. Every star you can see with your naked eye, and countless more you can't, likely has planets of its own, silent, spinning worlds, most of which we will never visit, never even properly see, orbiting endlessly, exactly the way our own Earth quietly orbits our sun. Trillions of quiet, unseen worlds, turning slowly in the dark, each one keeping its own private rhythm, the same way your own small world keeps turning gently beneath you tonight. Number 16. Water older than the sun. Here is a soft, watery fact to hold on to for a while. Water is not something the Earth invented. Water, actual water, the same molecule that fills your glass at night, that falls as rain, that makes up most of your own body, has been found drifting through interstellar space, inside cold clouds of gas and dust, long before our solar system ever formed. Astronomers have detected clouds of water vapor around distant, forming stars that contain many times more water than exists in all of Earth's oceans combined. Vast, cold reservoirs of water ice, drifting slowly through space, some of it likely older than the sun itself. When our solar system began to form, roughly 4.6 billion years ago, some of that ancient water was folded into the material that became the Earth, and more of it likely arrived later, carried gently by icy comets, colliding softly with our young planet over hundreds of millions of years. Which means the water in the ocean, the water in the rain, the water resting quietly in your own body right now, may be older than the sun that warms it. It has drifted through the freezing dark of interstellar space, waited patiently inside slowly forming clouds of dust, and eventually, gently, found its way here, into rivers, into rain, into you. You are not only made of stardust, you are in part made of very old, very patient water, older than the star it's warmed by, that has simply been continuing its long, slow journey through comets, through oceans, through clouds, through your own body, for billions of quiet years. Number 17. Stars are born in nurseries, slowly. We often talk about stars dying, but let's spend some time now on how gently, how slowly they're born. Scattered throughout our galaxy are enormous clouds of gas and dust called nebulae, some of them hundreds of light years across. Within these clouds, gravity works incredibly slowly, patiently pulling together small clumps of gas over hundreds of thousands of years. As each clump grows denser, it draws in more material, spinning gently, warming gradually, until eventually, after perhaps 1,000,000 years or more, the pressure and heat at its center become great enough to ignite nuclear fusion. A new star is born. One of the most famous of these stellar nurseries is the Orion Nebula, visible even to the naked eye as a faint smudge below the 3 stars of Orion's belt. Within it, astronomers have identified hundreds of young, still-forming stars, some barely a few 100,000 years old. Infants, by stellar standards, still wrapped in the gas and dust clouds that are slowly giving birth to them. This process is unhurried, almost beyond imagining. A star takes, on average, somewhere between 100,000 and a few million years simply to form. And once born, many stars, especially smaller, calmer ones, will go on to shine steadily for billions of years afterward. There's something tender about picturing this. Vast, quiet clouds of gas and dust drifting slowly through the galaxy, patiently gathering themselves together in no rush at all, until eventually, gently, a new light switches on in the dark. Earth in the universe is rarely sudden. It's slow and soft, and takes exactly as long as it needs to take. Number 18. Almost everything we cannot see. Here's a strange, quiet mystery to end on. Most of the universe is invisible to us. As best we currently understand it, ordinary matter, the atoms that make up stars, planets, you, me, everything we've talked about tonight makes up only about 5% of the universe. Roughly 27% is something called dark matter, matter that doesn't emit or reflect any light, that we can't see or touch directly, but whose gravity we can detect through its effect on galaxies and stars, holding them together in ways ordinary matter alone couldn't explain. The remaining 68% or so is something even stranger, called dark energy, a mysterious force that appears to be causing the expansion of the universe to accelerate, pushing galaxies apart from each other a little faster with each passing year. We don't fully know what it is. We can measure its effects carefully, patiently, but its true nature remains one of the biggest open questions in all of science. Which means almost everything about the universe, the vast majority of it, remains quietly beyond our full understanding. We are, in a very real sense, surrounded by mystery, all the time, in every direction. And rather than being unsettling, there is something almost restful in that. We don't have to understand everything. Scientists spend entire careers gently, patiently studying just a small piece of these questions, adding one careful observation at a time, with no expectation of solving it all at once. You don't have to understand everything either, not about the universe, and not about your own life. It's all right to rest inside a little bit of mystery. The universe itself, for all its vastness, is still figuring itself out, one patient observation at a time. Number 19. The moon is slowly leaving us. The moon has probably been there for every night of your life, quietly rising, quietly setting, so familiar that it's easy to stop really noticing it. But there's a lot happening in that quiet presence. Most scientists believe the moon formed about 4.5 billion years ago, very early in Earth's history, after a Mars-sized object collided with the young Earth. The debris from that enormous ancient collision gradually gathered together in orbit over a surprisingly short span of time, perhaps only a few decades to a few centuries, astronomically speaking, forming the moon we see today. Earth and moon, in a sense, are siblings, born from the same catastrophic event, shaped from much of the same material. Here's something gentler to sit with. The moon is moving away from us. Very, very slowly, but steadily. The moon drifts about 3.8 centimeters further from Earth every year, roughly the rate your fingernails grow. It's caused by the same tidal forces that pull our oceans into rising and falling tides. As the moon tugs on Earth's oceans, Earth's rotation very gradually transfers a tiny bit of energy back to the moon, nudging it outward year after year for billions of years. It's happening too slowly for anyone to notice in a single lifetime, or even in all of recorded human history combined. But it means the moon you see tonight is very slightly closer than the moon your distant descendants will see millions of years from now. And it means billions of years ago, the moon would have appeared strikingly larger and brighter in Earth's sky than it does now. A quiet, gradual drift outward that has been unfolding since long before there was anyone here to watch it happen. There's also a soft, quiet fact about moonlight itself. The moon has no light of its own. Every bit of moonlight you've ever seen is simply reflected sunlight, bounced off the moon's pale, dusty surface, and sent gently back down to Earth. So the soft glow of a full moon on a clear night is, in a very real sense, sunlight, borrowed and softened, traveling first to the moon, and then all the way back down to you. A quiet companion, slowly drifting away, glowing only with borrowed light, and still, for all of human history, one of the most comforting sights in the night sky. Number 20. The slowest, grandest spin you'll never feel. Right now, wherever you are moving. Not just spinning with the Earth's rotation, and not just orbiting the sun, you are also, quietly, being carried along on a much, much larger journey. Our entire solar system orbits the center of the Milky Way galaxy, and it does so at an astonishing speed, roughly 230 kilometers per second, or more than 800,000 kilometers every hour. And yet, despite that almost unimaginable speed, it takes our solar system somewhere between 225 and 250 million years to complete just one full orbit around the galaxy's center. This span of time is sometimes called a cosmic year. Think about how long that actually is. The last time our solar system was in its current position in its orbit around the galaxy, dinosaurs hadn't yet appeared on Earth. The continents were arranged completely differently. It has taken our solar system this entire span, one full slow turn around the heart of the galaxy, just to come back, around to roughly where it started. And despite moving at 800,000 kilometers an hour, you feel none of it. No wind, no pull, no sense of motion at all. You are traveling through the galaxy at a truly enormous speed right now, while sitting or lying almost perfectly still. There's something wonderfully calming in that contrast. Enormous, majestic motion can still feel like perfect stillness if it's smooth enough, steady enough, patient enough. You are being carried right now through the vast turning wheel of the galaxy at a speed almost too large to picture, and it feels exactly like doing nothing at all. Rest, it turns out, doesn't require standing still. Sometimes the deepest kind of rest is simply moving so smoothly, so steadily, that it feels like calm. Number 21. A collision, 4.5 billion years in the making. Here's a fact that sounds dramatic, but unfolds so slowly that it's actually one of the gentlest events imaginable. The Andromeda Galaxy, our nearest large galactic neighbor, is currently about 2.5 million light-years away, and it's moving toward us, slowly but steadily, at around 110 kilometers per second. In roughly 4.5 billion years, astronomers expect the Milky Way and Andromeda to begin merging into one another. It's tempting to picture this as a violent crash, like two objects smashing together. But galaxies are, overwhelmingly, empty space. Remember, the distances between individual stars within a galaxy are so enormous that the actual likelihood of any two stars colliding during this merger is almost zero. Instead, the two galaxies will slowly drift into and through one another, their shapes gradually distorting, gravity gently pulling gas and dust into vast new streams, star formation quietly picking up in places over the course of not seconds or years, but hundreds of millions of years before the two galaxies eventually settle into a single larger galaxy. If humans, or something descended from us, were somehow still around to watch it from Earth billions of years from now, this collision wouldn't look like a single event at all. It would look like an achingly slow, graceful, almost imperceptible reshaping of the night sky, Andromeda growing larger across the sky. Over millions of years, its shape slowly bending and merging with our own galaxy's spiral arms, so slowly that entire human lifetimes, one after another, might pass without anyone noticing much change at all. Even the most dramatic-sounding events in the universe, two galaxies merging, happen in practice with an almost unbearable gentleness, spread out so patiently across time that collision barely feels like the right word anymore. Perhaps meeting is closer. A slow 4 billion year meeting between two old galaxies, drifting quietly together across the dark. Number 22. A web woven from galaxies. Zoom out far enough, past our galaxy, past our neighboring galaxies, out to the very largest scales we can observe, and something remarkable happens. The universe stops looking random and starts looking woven. On the largest scales, galaxies aren't scattered evenly through space. They're arranged into enormous structures, long filaments and sheets of galaxies, stretching across hundreds of millions of light years, separated by vast, mostly empty regions called cosmic voids. Together, this pattern is often called the cosmic web, a vast, gently curving lattice of galaxy clusters and filaments, with huge quiet gaps between them, spanning the entire observable universe. Some of these filaments are almost too large to describe gently. One structure, sometimes called the Great Wall, stretches across hundreds of millions of light years, containing thousands upon thousands of galaxies strung loosely together like beads of light along an invisible thread. And the voids between these filaments can be even larger still. Vast regions of space, hundreds of millions of light years across, containing only a scattering of galaxies, quiet and mostly empty, like great calm clearings in an otherwise glowing forest. This structure formed slowly, patiently, over billions of years, as gravity gently amplified the tiniest ripples and unevenness left over from the very early universe. The same ancient light we talked about before in an earlier chapter contains the faint fingerprints of the ripples that eventually grew into this entire cosmic web. There is something deeply peaceful about zooming out this far. From here, individual stars disappear. Individual galaxies blur into soft strands of light. All that's left is a vast, quiet structure, woven slowly over unimaginable spans of time, so large that human concerns, human timelines, Even entire human civilizations would be far too small and far too brief to even register as a flicker within it. And yet, somewhere within one small filament of that enormous cosmic web, in one small galaxy, around one small star, here you are. Number 23. Humanity's farthest traveler. Let's bring our attention back down for a while to something small, human-made, and very far away. In 1977, two spacecraft named Voyager 1 and Voyager 2 launched from Earth, originally intended to study the outer planets of our solar system. They did that beautifully, flying past Jupiter, Saturn, Uranus, and Neptune, sending back some of the first close-up images humanity had ever seen of these worlds. But their journey didn't stop there. Both spacecraft kept going and going and going. In August 2012, Voyager 1 became the first human-made object to leave the heliosphere, the vast bubble of particles and magnetic field blown outward by our sun, and enter true interstellar space, the space between stars. Voyager 2 followed a few years later. As of now, both spacecraft are still traveling, still sending back faint signals, more than 20 billion kilometers from Earth, farther from home than any human-made object has ever been. Each spacecraft carries a small, golden record, an actual physical record, the kind you might play on a turntable, containing greetings in dozens of human languages, sounds of Earth like wind, rain, and birdsong, and a curated selection of music from around the world, along with instructions etched gently into the cover for how to play it, just in case, someday, something out there ever finds it. At their current distance and speed, it will take the Voyager spacecraft tens of thousands of years just to approach the distance of the nearest stars, and they aren't even aimed at any particular star system. They will simply keep drifting quietly, slowly, carrying their small golden record of Earth sounds and Earth voices out into the dark for what could be millions of years, long after Earth itself has changed beyond recognition, long after anyone currently alive is remembered by name. There is something profoundly touching about that. A small, quiet, human-made object carrying a little piece of home, drifting gently through the vast dark forever, asking nothing, expecting nothing, simply continuing outward, patiently, the way so much of the universe seems to. Number 24. The color of everything, all at once. Here's an unusual, gentle little fact. Astronomers have actually calculated the average color of the entire universe. By gathering light from hundreds of thousands of galaxies and combining it all together, researchers found that if you could somehow blend the light from every star in the observable universe into one single average color, it would come out as a soft, warm, near-white shade with a faint tinge of pinkish beige. The team who discovered this, slightly playfully, nicknamed the color Cosmic Latte. It's a strange thing to think about, that amid all the vivid blues, fiery oranges, and brilliant whites of individual stars and nebulae, if you were to gently mix the light of the entire universe together, evenly, it would settle into something as soft and warm as a cup of coffee with cream. Not harsh, not cold, not the deep black we usually picture space to be when we imagine it only as darkness between the stars. On average, warmly, gently, the universe leans towards something soft and pale, almost the color of morning light. It's a small, playful fact, but there's something oddly comforting in it too. For all its vastness, for all its violence in places, exploding stars, colliding black holes, crushing gravity, when you average it all out, when you step back far enough and blend it all together, the universe settles into something gentle, something the color of warm milk in coffee, something soft. Number 25. Lights born from collision, beautiful because of protection. Let's return gently to something you may have actually seen with your own eyes. The aurora, the northern and southern lights. We talked before about Earth's magnetic field quietly deflecting most of the charged particles streaming from the sun. But not all of it is deflected away completely. Near the planet's magnetic poles, some of those charged particles are gently funneled down into the upper atmosphere, where they collide with oxygen and nitrogen molecules high above the Earth's surface. Those collisions release energy in the form of light, soft curtains and ribbons of green, pink, violet, and red, rippling slowly across the night sky, usually somewhere between 100 and 300 kilometers above the ground. Green auroras come mostly from oxygen. The rarer reds come from oxygen even higher up. Blues and purples often come from nitrogen. The exact colors and patterns shift with the type of particle, the altitude, and the strength of the incoming solar wind. What's beautiful about this fact is what it actually represents. The aurora isn't just a pretty light show. It's a visible signature of Earth's protection at work. It's the planet's magnetic shield quietly doing its job, deflecting and funneling away a stream of energetic particles from the sun that would otherwise be far more damaging to the atmosphere and to any unprotected life on the surface. The soft, shifting colors in the sky are, in a very real sense, the glow of being defended. There's something moving in that. One of the most beautiful natural sights on Earth is, at its core, evidence of being cared for, protected, shielded, quietly, invisibly, all the time, whether you ever get to see the aurora with your own eyes or not. Number 26. The stars that will outlive almost everything. Let's end our journey through the stars with the quietest, most patient of them all, red dwarfs. Red dwarf stars are the most common type of star in the universe. By some estimates, they make up around 70% of all stars in the Milky Way. They're smaller than our sun, cooler, dimmer, and far less dramatic. You can't actually see a single one with your naked eye from Earth. Even the nearest star to our own sun, Proxima Centauri, is a red dwarf, and it's far too faint to spot without a telescope. But what red dwarfs lack in brightness, they more than make up for in patience. Because they burn their fuel so slowly and steadily, red dwarfs are thought to be capable of shining for an almost incomprehensible length of time. Some estimates suggest a small red dwarf could continue burning steadily for 1 to 10 trillion years. For comparison, the universe itself is currently only about 13.8 billion years old. A red dwarf star born today could, in theory, still be quietly shining when the universe is hundreds of times older than it is right now. In fact, because the universe isn't yet old enough for any red dwarf to have had time to die of natural causes, scientists believe that not a single red dwarf star anywhere in the universe has ever actually burned out since the universe began. Every single one that has ever formed may still be quietly shining somewhere right now. There's something deeply reassuring about the quietest, dimmest, least flashy stars turning out to be the most enduring of them all. Not the brightest, not the most dramatic, just steady, patient, and built to last far longer than almost anything else in existence. Sometimes the softest, most modest light is the one that keeps going the longest. Number 27. Life's quiet stubbornness. Let's come back to Earth, gently, for one more thought before we close about how persistent life itself seems to be. Scattered across our own planet are creatures that seem almost designed to prove how far living things can stretch. Tardigrades, tiny, 8-legged creatures barely half a millimeter long, sometimes nicknamed water bears, can survive being frozen to nearly absolute zero. Heated well past the boiling point of water, dried out almost completely for years at a time, and even exposed directly to the vacuum of space, all by entering a kind of deep, dormant, suspended state, and later simply waking back up again, quietly, as if nothing had happened. Deep beneath the ocean, around scalding volcanic vents on the sea floor, entire ecosystems thrive in complete darkness, without sunlight at all. Drawing their energy instead from chemical reactions in the Earth's crust. In Antarctic ice, in boiling hot springs, in the crushing pressure of deep ocean trenches, in highly acidic pools, in rock kilometers underground, wherever scientists have looked closely enough, they have tended to find some form of life quietly persisting, adapted patiently to conditions that would seem, at first glance, completely impossible to survive. This matters for how we imagine the rest of the universe, too. If life on Earth can be found this stubbornly, this quietly, in so many extreme and unlikely corners of our own planet, it gently raises the possibility that life elsewhere, on a moon of Jupiter or Saturn, in a distant ocean beneath a thick layer of ice, around some other patient star entirely, might be more resilient and perhaps more common than we once assumed. There is something comforting in life's quiet stubbornness. It doesn't need perfect conditions. It doesn't need everything to be easy. Life, wherever we look closely enough, tends to find a way to continue quietly, patiently, in whatever conditions it's given. Number 28. A pale blue dot. In February 1990, the Voyager 1 spacecraft, the same one we talked about earlier, now billions of kilometers from home, turned its camera back around at the request of scientists on Earth and took a photograph looking back toward the inner solar system from a distance of about 6 billion kilometers. In that photograph, Earth appears as a single pale blue point of light, less than a pixel wide, suspended in a faint band of scattered sunlight, surrounded by the vast darkness of space. Everyone who has ever lived, every human being, every love, every war, every quiet, ordinary evening like this one, every bit of it happened on that one small, pale, barely visible dot of light. From that distance, there's no visible difference between continents, no visible cities, no visible evidence of anything we've built or done at all. Just a small, pale blue point, suspended gently in a sunbeam, floating quietly in an almost unimaginable amount of dark, empty space. And yet, here you are, resting safely on that small dot tonight, made of stardust and ancient water, held gently by an invisible magnetic shield, illuminated softly by borrowed moonlight, carried at astonishing speed through a vast turning galaxy that itself feels perfectly still. All of tonight's facts and all the facts from every other night come back to this same small, quiet place, one pale blue dot drifting gently, patiently through an old and endlessly unfolding universe. You don't have to hold on to anything else from tonight. Just that, a small, warm blue dot, and you quietly resting somewhere on it. Number 29. Jupiter, the quiet guardian. Let's turn our attention to Jupiter for a while. The largest planet in our solar system, and in a gentle way, one of Earth's quietest protectors. Jupiter is enormous, more than 300 times the mass of Earth, and more massive than all the other planets in our solar system combined. That enormous mass gives it an enormous gravitational pull, and for a long time, many astronomers believe Jupiter played an important role in shielding the inner solar system, including Earth, from some comets and asteroids that might otherwise wander in from the outer solar system. The idea is that Jupiter's powerful gravity can capture, deflect, or fling away many objects that might otherwise drift into the paths of the inner planets, including our own. One especially memorable example came in 1994, when a comet called Shoemaker-Levy 9 broke apart and collided directly with Jupiter, in full view of astronomers on Earth. The impacts left dark, bruise-like scars in Jupiter's atmosphere, some larger than Earth itself, visible through telescopes for months afterward. It was a dramatic, visible reminder that Jupiter, simply by being so large and so gravitationally powerful, absorbs impacts and deflects objects that might otherwise, over the long run, have found their way toward us instead. More recent research has shown the full picture is a little more complicated than a simple shield. Jupiter's gravity also flings some objects inward, toward the inner solar system as well as away. But even with that complexity, Jupiter's enormous, quiet presence in the outer solar system has clearly shaped, gently and constantly, the paths of countless smaller objects for billions of years, in ways that have influenced how calm or chaotic the inner solar system, our solar system, has been able to remain. There's something comforting about picturing Jupiter out there right now, vast, quiet, storm-streaked, doing this slow, steady gravitational work in the dark, mostly unnoticed, the same way so much of what protects us tends to go unnoticed, simply continuing patiently in the background. Number 30. The comet that keeps its promise. Let's close tonight with a small, old, quiet promise kept over and over again across human history. Halley's Comet is one of the most famous comets in the sky, not because it's the brightest or the largest, but because of its patience. It swings by Earth roughly once every 76 years, following a long, elliptical orbit that carries it far out past the orbit of Neptune before slowly, gently, curving back in toward the inner solar system and toward the Sun once again. Records of Halley's Comet stretch back over 2,000 years, appearing in ancient Chinese, Babylonian, and European records, long before anyone understood it was the same object returning again and again. Edmund Halley, in the early 1700s, was the first to realize that several previous comet sightings, recorded decades apart, were actually the same comet, following the same long looping path, and he successfully predicted its return in 1758, 16 years after his own death. The comet last appeared in 1986, and it's expected to return again in 2061, which means Halley's Comet moves on a timescale that stretches comfortably across a single human lifetime. Many people alive today may get to see it twice, once in childhood or young adulthood, and once again much later in life, decades apart, the very same quiet, icy visitor returning right on schedule, exactly as it has for thousands of years. There's something deeply reassuring about a promise kept that reliably across a timescale that long. Whatever else changes, whatever else happens across those 76 years, Halley's Comet keeps its slow, patient orbit and keeps coming back. You don't need to remember exactly when. You only need to know that some things out there keep their promises gently, across decades, across centuries, across thousands of years, without fail. Let your breathing slow now, one more time. Everything we've talked about tonight, the quiet black hole at the center of our galaxy, oceans hidden inside small icy moons, a bubble of solar wind wrapped gently around everything we know, ancient star cities orbiting patiently at the edge of the galaxy, a photograph of nothing that turned out to be full of everything, and a small, icy comet keeping its slow promise across the centuries. All of it continues, quietly, whether you're awake to hear it or not. Rest now. You're allowed to. Good night.